Okay, I want to go ahead and talk about graphing a little bit more, but I also want us to start practicing how to find other polar coordinates with certain restrictions. So we're first going to go ahead and graph this coordinate -4, 3 pi, and then we're going to go through each of these three parts to find alternative polar coordinates that actually, alternative ways of writing the same polar coordinate. Okay, so -4, 3 pi. First off, I need to figure out where 3 pi is. Now, full rotation is 2 pi. So if I just take away a full rotation, we'll find that 3 pi is coterminal with 1 pi. So that's along here. Okay. However, if you recall previously, I said there's something special we have to do if our radius is negative. So you go exactly 180 degrees opposite that. So the angle that'll give you a straight line with the line I already drew. So we're going to go this direction. And we're going to go 4 along that because we're kind of going back 4 from pi, going backwards 4. Okay, so that's this coordinate right here. Now, with these values, each one of them has some sort of restriction with our r. I'm going to talk about that first. The restriction with your r just tells you whether or not your radius is going to be positive or negative. So if it says the r is greater than 0, that means you're going to have a positive radius. If it's less than 0, then you're going to have a negative radius. Okay. Then it gives you some restriction on the angle, or theta. So for instance, on this first one, we want the angle to be between -2 pi and 0. And the next one, we want it to be between 0 and 2 pi and so on. So we're going to go ahead and go through that. Let's go to part A first. So according to the radius on part A, we need the radius to be greater than 0, so it needs to be positive. So it'll be a +4. You don't change the value of the radius, it's just whether or not it's a positive or -4. Now, we need the angle to be between -2 pi and 0. Now remember, it was +4, so we're basing it off of this point. Since it's +4, we actually want the angle to land on this line, okay, on the polar axis, since it's +4, because we actually will go along, from the pole, we'll go along that specific line. For that reason, we actually will want to use -2 pi. Okay, because -2 pi is coterminal with 0, it's also coterminal with 2 pi, and so on. So -2 pi should have gone out this way, it goes clockwise. Okay, so that's our first one. Let's go to part B. So this time, we want r to be less than 0. That means we want it to be a -4. Now this is tricky because now that we want it to be a -4, that means we don't want our terminal side to be on the polar axis. We want it to be on the opposite side, so on this side. Okay, so we want it to be coterminal with pi, or it needs to be pi, so we'll find out. So it needs to be between 0 and 2 pi. So this right here, this line right here is pi. Well, pi is between 0 and 2 pi, so I can just simply put pi. And then we'll go to part C. Part C, we need it again to be a +4. So remember, +4 means I need it to be coterminal with 0 or 2 pi, so right here. And this time we want it to be between 2 pi and 4 pi. It can include 2 pi, it can't include 4 pi. So this is 0, this line is 0, and it also is 2 pi, so I'll go ahead and put 2 pi because that's within the range, and we're good. There are our 4 different ways of writing the same polar coordinate. Now let's go ahead and do another one because this can be kind of the trickiest part of the homework. So I'm going to go ahead and graph 3, 7 pi 6. So 7 pi 6 is right here. And I want to graph 1, 2, 3 right there. Okay. Now for letter A, now that we've graphed that, we want r to be positive. So that means we're just going to keep it at +3 since it's greater than 0. Now we want theta to be between -2 pi and 0. So since it's a +3, we want the angle to land on this terminal side. And we do want it to be negative, though. That's basically what this is saying. Since we want it to be between negative 2 pi and 0, we want to find a negative coterminal angle. So there are two different ways you could do that. You could take your original angle. I'll show you this method way first, and just subtract 2 pi. Now this is the same thing as taking 7/6 minus 2, get a common denominator, and so on. You'll get negative 5 pi 6. Second method is, if you remember my little trick, remember if we want a negative angle, this angle right here is 5 pi 6, which means negative 5 pi 6 would be a direct reflection over the x-axis, so it would be negative 5 pi 6 right here. Okay, so that's just another trick you could use to find that value. Okay, let's go to part B. Here, I'll switch colors for part B. So part B, we want, I accidentally erased our point. There it is. For part B, we want the radius to be a negative 3. Okay, which means since it needs to be a negative 3, this is our coordinate. That means our coterminal side needs to be the side I am putting in red. It needs to be that angle that's exactly 180 degrees away from the angle we're currently on. Now it needs to be between 0 and 2 pi, so that's easy. We just need to name this angle right here, like we're used to naming it. So that's the angle pi 6. And we'd be done with that one. Last but not least, I'll switch colors again. We are going to part C. Part C, we want a positive radius again, so positive 3. But this time, we want it to be the angle to be between 2 pi and 4 pi. Now, positive 3 means I still want my coterminal. Oops, that was too much. There we go. I want my angle to be between 2 pi and 4 pi, but this angle will be coterminal with 7 pi 6. So one way to do that is take 7 pi 6 and add 2 pi to that, so that you can get a common denominator. You'll end up with 19 pi 6, which is 19/6 is greater than 2 but less than 4, so I know it's within that range. And there you have it. You have your 3 coordinates for each of those stipulations.